Hey guys, this is Fozan, and today we're going to be discussing the math class. No, not the math class that you have at school, but rather the math class that you have available to you through the Java programming language. So our lesson objectives: learn the methods within the math class, and then learn how to use the math class to get random numbers, which is probably the most important concept that you have to get out of this video. So unlike the scanner class, you don't have to import the math class because the math class is part of the java.lang package, and the java.lang package is available to you automatically through your compiler. So no import statement. With the math class, we're able to utilize a variety of mathematical functions into our Java program rather than programming it ourselves. If you remember from our for loop or while loop, whatever video it was, we were programming a bunch of stuff to do a bunch of mathematical stuff that we wanted to do. However, it's nice to know that we have a bunch of methods available to us that allow us to do those respective functions in just one line or a couple lines. So the four methods we're going to be discussing, there are more methods, but we're going to be discussing four methods: the absolute value methods, exponents methods, the exponent methods, exponent method, it's not plural, square root method, and then the random numbers method. So the only method that is plural in this video should be the absolute value method, because there are two methods. But before I explain what the absolute value methods are, let me explain to you what absolute values actually are. Absolute value is the distance between a number and the number 0. So if you have a number, the absolute value is the distance from 0, and distance is measured in only positive numbers. It's a scalar value. So the easiest way to remember it is just keep the positive numbers and make the negative numbers the same number but positive. So if you have a value, if you're given a number 5, the absolute value is still the same number, 5. 5 is the distance away from 0. Same with negative 3, except negative 3 you have to alter it. So the absolute value for negative 3 is 3 because it's 3 spaces away from 0. That's the distance away from 0. There are two methods with the absolute value, and they differ mainly just really only by their arguments and return type. So if you give it an integer, it's going to return to you an integer. If you give it a double, it's going to return you a double. I provided you two examples, math.abs, and if you input negative 3, it's going to give you back 3. There is no decimal after it. But if you give math.abs 3.14, it's going to return 3.14. Negative 3.14 is going to give you 3.14. So let's try it out on the compiler. Let me erase all this, comments, and let's run the program. And as you can see, it returns us 3, 3.14, and 3.14. So if you give them an integer, if you give them the abs method an integer, it's going to return you an integer. If you give it a double, it's going to return you a double. As I said before in my previous videos, since these are static methods, in the declaration you see the static value, you don't actually create a math object. It's heavily advised that you don't create a math object because these are static methods. And since these are static methods, there are already space allocated for these methods. So you don't have to worry about creating an object. And really the only way that you can access these static methods is by simply calling the name of the class. The name of the class being math. Let me make these comments again so they don't interfere with our other statements that we're going to execute later. So as you might have saw, exponents is our next method. What is an exponent? So exponents are basically multiplying a number by itself by a certain number. So we're given a base of 2, and then the 3 over here is usually in a superscript, and meaning that's elevated above the 2. And this implies how many times 2 should be multiplied. So 2 is the base, so that's the number we're multiplying, and 3 is the exponent, the times that we're multiplying it by. So we multiply 2 3 times. 2 times 2 times 2. What is that? 2 times 2 is 4. 4 times 2 is equal to 8. As you could see, we could see the respective change when we reverse the numbers. So if you have a base of 3 and an exponent of 2, 3 becomes the number we're multiplying, and we multiply it how many times? The exponent amount of times. So 3 times 3, we do it 2 times, that is equal to 9. The exponents method is not just like, the abs method. It has a different abbreviation, or rather a different method name, and it has 2 arguments. So just like the abs method, it's static. So again, you're calling it by math. You're not creating an object. It's going to return you a double, so there is no integer, and you call it through POW, and the base here is going to be the base that you're going to multiply. So it's the number that you're multiplying by, and then the exponent is your superscript, or the thing that comes after the caret. And that's how many times you multiply the base by. Here are 2 examples of the exponent method being in use. So we print out math.pow 3 to the power of 3. What is 3 to the power of 3? Well, 3 times 3 times 3 is equal to 3 times 3. 3 times 3 is equal to 27. 3 times 3 is equal to 9. 9 times 3 is equal to 27. And since it's going to return a double, it's going to return 27.0. And even if you give it an integer, it's going to convert it to a double. There is no lossy conversion from integer to double. There is a lossy conversion from double to integer. However, we don't have that case with the math class. Another example is 2 to the power of 4. So we're multiplying 2 4 times. 2 times 2 times 2. 2 times 2 is equal to 4. 4 times 2 is equal to 6. 4 times 2 is equal to 8. And then 8 times 2 is equal to 16. And again, it's a double that's getting returned. So here's an example of us using it in our class. So 3 times 3 times 3, 27. So this should hopefully return 27.0. 2 times 2 times 2 times 2, that should be 16. 27.0 and 16.0. Square root is just like how you were taught in your math class. It's basically splitting the number into 2 multiples of the same value. So the square root of 9 could either be -3 or +3, because -3 times -3 is equal to 9. 3 times 3 is also equal to 9. So -3 plus or minus 3 is the square root of 9. Same thing with 16, but like with a different square root. So what is the square root of 16? Well, it's plus or minus 4. Plus or minus 4 because -4 times -4 is equal to 16. +4 times +4 is also equal to 16. The easiest way that you can get the square root, besides just basic memorization through your times tables, is just simply bringing the value to the exponent of 1/2. So what is 9 to the power of 1/2? Well, that's going to be 3, or rather -3 as well. 16 to the power of 1/2 plus or minus 4. The square root method returns a double, but it also gets in the double. Even if you give it an integer, it's going to convert it into a double. And the identifier that we have for it is x. So whenever you input something into the square root method, it should be greater or equal to or greater than or equal to 0. An example of this is if you print out math.sqrt 9, and it should return you 3.0. So I have 2 examples, one where I have a integer and the other one where I have a double. This should return us 5 because, 5.0, because the square root of 25 is 5.0. 9, the square root of 9, just like I said in the slide, should be 3.0. As you can see, we get our respective square roots. So random numbers are interesting because through casting, that's the wrong slide. Let me get the slide up. Okay. So the random numbers method is interesting in that although the basic use of it is not practical for our algorithms, we can adjust it so that it makes more sense. So we have a static double random method signature, meaning that it returns a double, But the only doubles that it returns are values in between 0 and 1. And it's including 0, but it excludes 1. So math.random will never return 1, but it could return 0. That is not off the table. And really, like, these decimals between 0 and 1, I'm not judging on your algorithm, but most algorithms won't need a random number in between 0 and 1, more specifically a random decimal for that matter. So we can adjust the range for our benefit. So we can adjust the maximum value easily by simply multiplying the maximum value. So let's say if we want to assign a random number in between 0 and 21, and we want that value to be sent into x. We want that to be stored into x. So we declare double x equals whatnot, right? And then our algorithm is there for getting a number in between 0 and 21. And this allows us to get a number in between 0 and 21, because what happens is that 0.99999 gets multiplied by 21, and now we have a new max value. So if we multiply 21.0.999, we get 20.99999. That is much more suitable if we want a maximum value, or rather if we want a range between 0 and 21. So if you want to keep 0, but you want to expand upon the maximum value, you want to convert it to, let's say, 5, you just multiply the math.random method by 5. We can also increase the minimum value. So let's say if we want to multiply, let's say if we want to assign a random number in between 8 and 9. Now I'm using 8 and 9 for a very specific purpose, because it's just like 0 and 1 in that the difference in between the numbers is, well, 1, right? So the difference between 0 and 1 is 1. The difference between 8 and 9 is 1. This is important because when we're trying to combine a new minimum and maximum value with different numbers, it's going to be a little bit different than this. But just for the sake, if you have a distance of 1, right? If you have a distance of 1 and you want to increase the minimum value, it's very easy. So you just simply add the minimum value that you want. So 8 is my minimum value, so I just add 8 into my math.random equation. And basically the biggest number that we can get from this is 8.9999999. But the lowest that we're going to get, since math.random can spit a 0 out, right? 0 plus 8 is equal to, well, 8.0. So in that regard, we have a minimum number of, well, 8. So this is the equation if you want to adjust the minimum and maximum value at the exact same time. What you do is that you subtract the max value by the minimum value. So if you look at the previous example, my slide is a little bit slow there, 8 and 9, there's a difference of 1. So technically speaking, you multiply 1 to this entire equation, but what is something multiplied by 1? It's the same number, so we omit that. But here, let's say the difference isn't 1, it's a difference of 2. Well, in that case, we're multiplying the math.random value by 2. So this is the equation: max value minus min value times by math.random in method invocation. I hope that's a real word, but like you're invoking the random method, and then we add the minimum value, because this can spit out 0, and if that spits out 0, any number multiplied by 0 is 0. So if you add that to the minimum value, then we get the minimum value. So 0 plus the minimum value is equal to the minimum value. So let's say if we're given an assignment, assign a random number in between 6 and 9 to x. Well, we can subtract 9 from 6, because 9 is the maximum value and 6 is the minimum value. So what's the difference between 9 and 6? Well, it's 3, so 3 is the number that we're going to be multiplying to the math.random function. And since the minimum value is 6, the minimum value, then we add 6, because again, if math.random spits out a 0, we want to make sure that 6 is there to bring it up, right? So what is 3 times 0? 3 times 0 is 0. 0 plus 6 is 6. And we know that 0 is the lowest number that math.random can spit out. So let's try it out on the compiler. Okay, so we have system.out.println 3 times math.random plus 6. As you can see, it's now spitting out numbers between 6 and 9. That's very nice. Now, it's very important to mention random integers specifically because really we can use doubles in our algorithms, but again, you're more likely to use random integers. It just seems to make more sense. Maybe if you're picking someone randomly in class and teachers assign numbers like we do like the teachers do all the time, right? Every student gets a number, and then you maybe want to have the computer pick out a number, a random integer, and a double would not be suitable for that respective algorithm. So just like in one of our videos, how do we convert from double to integer? We do that through casting. Through casting, we can change the return value of the math.random function to an integer. We will also have to we'll also have to learn how to adjust the scaling and shifting factors in order to encompass our range. So there is a different set of rules, not necessarily set of rules, but a different way of calculating how to do random integers altogether. So let's say if we want a random integer between 0 and, 68. Well, since it can spit out 0, we don't need to add any values because 0 is within our range. However, we do want 68 to be within our range. So in that case, we would have to bump up the number. So 68 now has to become 69. Why do we do this? Well, the reason why we do this is because we have to think about how Java truncates a decimal. So remember, math.random spits out decimals, but it never spits out. I know I keep saying spits out, but the more proper term to use, it never returns 1. This function over here never returns 1. So let's say if we have 0.99999, which is a value that is possible, and if we multiply that by 68, what happens? Well, what happens is that we get a value such as 67.9. Now, 67.9 is good. It's within our range. But if that's one of the biggest values that we can get, then we have a problem because 68 never comes within our range. Because what happens? Java doesn't round 67.9 to a 68. What it does is it just cuts off the 0.9 off. It cuts off the 0.9. So it will never be 68. So that's why we bump up 68 to 69, and 69 will allow us to include 68 within our integer range. So what is 0.99999 times 69? I'm going to calculate here to get a more accurate result. 0.999 times 0.999 times 69. And we get 68.9999. Basically, we get very close to 69, but we never actually hit 69 because what happens is that Java is going to cut off the 0.9 and the 0.99999, and it's going to be 68. So that is very important to mention. So we bump up the number in that regard. So this is your general formula for a random integer. So we have our allocation for integer space, and then we have our casting keyword. So we have that in parentheses to cast the double that we get from all of this into an integer. J is going to be our scaling factor, and then M is going to be our shifting factor. The last value of our range is going to be equal to M plus J minus 1. So this is a very handy dandy tool to allow us to get the proper M or J value. So we're given the task of finding a random integer between 7 and 30. So that is going to be our range. We have our integer x is equal to integer the casting math.random times j plus m. So we already know that we're shifting by a value of 7. So what do? We replace m with 7, because if math.random spits out returns 0, right, this entire thing becomes 0. And we don't want 0 to be the minimum value, so we add 7. 0 plus 7 is equal to 7. We also know that the last value is 30. So we use the previous equation. Last value of the range is equal to m plus j minus 1. So we have 30 is equal to m plus j minus 1. So we put in the m value because that is our shifting value. And then we just do a simple algebraic, basically some algebra, and we get 24. We subtract 7 from 30, and then we add 1. It should be 23 is equal to j minus 1. J is equal to 24. So we replace j in our initial equation with 24. Let's see how it looks in the compiler. So what I did was that I declared an integer x, and then with integer x I stored the value, and this should return a value between 7 and 24, an integer value to be more specific, and then we just print out the integer. Let's save the program, and we get, well, an integer, right, just like we wanted, but more specifically regarding this integer, it's an integer between 7 and 20. So if we keep running the program, we're going to get an integer between 7 and 30. 30 inclusive, as you just saw there. And that basically wraps up my video on the math class. I'll make sure to make the code available by removing the comments that we have in this video. Thank you.